Okay, so this last video for this week, we're going to actually look at doing a pad stack for a surface mount component. Now, there's one thing that I need to fix. I made a very critical error when I talked about the naming convention. So hopefully you're watching all the videos. The naming convention here, I forgot that the way that it actually works here is that, let me scroll back up here a little bit. And I'm going to write tiny here. It's plus capital H plus hole diameter. Because otherwise, the reality is these numbers run together and it can lead to confusion. So the reality is this should have been 150H 90 is what it should be. And so for the one that we just made, if I open my pad stacks, where are my pad stacks here? The one that I just made here starts with a C. This one right here. I should have named it as C130H, and they say capital letters. It doesn't really matter if they're capital or lowercase in reality, but C130H90. Okay? So now, as I said, what we want to do is we want to now get on to doing surface mount components. Now this data sheet is actually for an LM386. This is a really good data sheet. Gives us a lot of examples here and a lot of information. Because actually, if I scroll up, this is actually the dimensions of the component. But that's why I like to look at everything, because if I scroll down a little bit more, here's even an example board layout. And so it says land pattern example. So exposed metal shown. And so these are basically gives you precisely what it is. And this 8x just means it's 8 times, meaning that each one of these are the same dimension. And 6x, well, that's because there's 6 of these dimensions in here. So we also need to make sure that we see linear dimensions are in inches and then brackets are in millimeters. Okay. So we're going to, again, use millimeters for this pad stack. So I'm going to go here and I'm going to do a new. And you can just by default pad stack usage, all that does is it's just going to select this for us automatically. Now, for an SMD component, it's SMD, which stands for surface mount device, and then we're going to do the naming convention that we're going to follow here is where we're going to do the width of it, which is always, well, I should be careful. It's almost always this longest side, and then the height here. So we're going to do W, SMD, W for width, 1.55, sorry, 155, height, 60, because it's 0.6. I'm just reading that directly off the data sheet. So width 155, height 60. I'll double check that standard just to make sure, but I'm fairly certain that's the standard naming convention for a surface mount pad. So if I go to my pad stack editor, I now add a normal pad here, and you can see, oh yeah, it's literally just moved it here to this SMD. And default pad geometry, again, in this case it's rectangle, or you can actually do a rounded rectangle. And it actually is a rounded rectangle, and you can see that it's a rounded rectangle because well, if you zoom in, you can see that it's rounded. But it also gives you this here, R, which stands for the radius here, and it's 0.05 millimeters, or 2 mils. So it's not really a rectangle, it's a rounded rectangle. There's reasons why we want that. Drill, well, by default, there shouldn't be any drill. So there's none. And that disables these 3 tabs here. And then we just have the design layer. And you can have adjacent layers, but really for surface mount components, there's really just the top layer. So begin layer, it's rectangular, go away, rounded rectangular. Now this is, again, the copper. And so remember, what was the width here? Just going back here. The width was 1.55. Again, make sure that your units are in millimeters. Mine are in millimeters because I didn't close the program out. I've been using the units of millimeters, so that's the reason it's staying in there as millimeters. But if you started the program up, make sure that you're in millimeters. So my width is 1.55, and then my height is 0.6. And so, yeah, it looks like a little rectangle. But now the corner radius, because remember it's rounded, is what they're recommending. And the rounded here is 0.05. And you can see now it didn't nip off the little corner there. Now typically for SMD components, we typically do have rounded pads, and there's a reason for having the rounded pads, but I'm not going to go into that reasoning. It's quite frankly, it's I don't want to say it's complex, but it's just not worth going into it right now on why we use rounded pads as opposed to like rigid square pads for these often. Well, I'm really almost done now. I have my mask layer, so I have my solder mask top, and remember, now it has solder mask bottom, but we're only having top here. So solder mask top, I may as well do rounded rectangle again. Now what is this? We said to add 0.07 millimeters. Well, let's look at the datasheet, because the datasheet actually has a solder mask opening that they are recommending. And look at what they say, 0.07 all around. Now, that's what this datasheet, that's not where I got the 0.07. I got the 0.07 from the standard. But it is interesting that, well, of course, they're following the standard as well, and they're putting it in there. And you can see here, IPC publication, and it's giving a note, may have changed. It's following the IPC standards. So that's what we're trying to teach here, is these IPC standards in this. Now, I'm not going to test you on the standards, but being exposed to those standards is actually very useful. I mean, you can actually put that on your resume that you've learned about IPC standards. You know, I wouldn't say that you're an expert at them, but you could definitely put that as, you know, a skill, especially if you're looking for an internship, because you can get internships where you're doing PCB layouts. Actually, you can make a lot of good money just doing this PCB layout stuff as a full-time job. We have a graduate from Tech. He graduated about, well, I think he graduated, I don't want to say number of years if I use this video again. Graduated, it's 2021. I think he graduated in like 2015 or 16. Any case, it doesn't really matter that much when he graduated, but this is what he does for a living. And so you can really make a good living doing this. Now going back here, 0.07 all around. Okay, well, we know here, my design layers, I just add 0.07. So 1.55 plus 0.07. If I do my math correctly, this would be 1.62. And then the height would be 0.067. All right, 0.67. Can't even do my, as if I do my math correctly. And then the corner radius stays the same. we've got a corner radius of 0.05. And the other thing you can notice here is you can actually determine if you want the corner radius on all corners, or you can take it off a corner, put it on. Now we actually have to do the paste mask top. Now I said the rule that we were going to follow, is 10% lower. But let's go to the data sheet here that we've been looking at, because it actually also has what it considers a solder paste example. Now it's giving the exact same dimensions of what the land pads are. This is where sometimes it's not good to do this, and it's basically saying, notes, this is laser cutting apertures with trapezoidal walls and rounded corners may offer best paste release. IPC 72525 may have alternate design recommended. Board assembly site may have different recommendations for stencil design. So board assembly site may have different recommendations for stencil design. That's basically where these boards are getting built, where these are being manufactured. And when I was working for the company I was working for, that was where I got the 10%. As I said, it's not necessarily standard. It was what my company that I worked for used for the solder paste stencil to reduce the dimensions by 10% roughly. So if I reduce it here, if I pull up my calculator, I have 1.55. Let's just multiply that by 0.9 because that's a 10% reduction. 1.395. I mean, that's kind of a little silly, but I may as well put all those things in here. 1.395. And then it's 0.6. 10% reduction would give me 0.54. And I will go ahead and keep the rounded corner in. And then there's nothing again on these bottoms here for the bottom layers. And so I'm ready to save. And I had already given it a name. Now, the naming convention I gave here is fine. SMD, surface mount device, width 155, height 60. But just like the other ones, we should tag our last name onto it when you're turning it in, so it's easy for me to see who it is that is turning it in. So really, it's not hard to make these pad stacks. What it is you have to look at the data sheet and then actually make the pad stacks based off the data sheet. So for your homework assignment, there's going to be a couple data sheets I upload, and you'll have to create pad stacks for the particular components there. Now, I'm going to scroll through this data sheet just a little bit before I end, because this actually has more than one type of package. So this, if I scroll up here, this first one was what's called an SOIC. That's a small outline integrated circuit, I think is what it's called, what this stands for. Fairly certain that's what, small outline integrated circuit. And then DIP, which is dual inline package, which that's the one we did the other. Now the nice thing is these are standard. If you look here, this was a different data sheet we were looking at, but it's still the same. If you look at the different data sheet and you look at this, it's the same, because these packages are standardized so that like once we get a pad stack set for this package, we'll be able to use that pad stack for any other component that has this type of package. But then we also have this plastic small outline. And if we go to the plastic small outline, there's different geometries, and it says, C note E and C, and then there's some other things here. And again, look, IPC. So there's 3 different packages there. So when I upload the data sheets, I will make sure to indicate what packages you need to do the landings for if there's more than one package. All right. So then after this, next week we're going to start getting into actually creating the footprints. But we'll also be posting our first project as well. So be looking out for that soon as well.